So I don't think it really matters on this one which side you worked on. So when I look at this, I see one thing either side. Right? I see a fraction on one side, and then I see a product on the other. Doesn't really matter, I don't think, which side you want to work on. Olivia, since you asked about this one, which side was your instinct to start on? Okay, perfectly reasonable. All right, so if I look at the left side, what part of the left-hand side is the thing that catches our eye? Yeah, the numerator, the cosine squared minus 1, looks almost like our modified version of P1. Right? What's the difference, though? The signs are the wrong way, right? I'm supposed to have a negative cosine squared and a positive 1. Well, how do I fix that? I factor out a negative 1. Is that okay? Now I have the 1 minus cosine squared that we were hoping for, right? So that's going to give me, I'm just going to write as negative sine squared. I used P1 that says 1 minus cosine squared is equal to sine squared. Olivia, are you okay there? Okay, look at where we're trying to get to. So we have the negative, right? And we have a sine. Well, we actually have two sines, right? Because we have a sine squared. So what if we go ahead and rewrite this as this, so that I can get that sine squared part separated from everything else? That's okay to do, right? Okay. So now I just have to figure out how to turn tangent, or I'm sorry, sine over cosine into tangent. That is tangent. That's exactly the identity. So we're done then, right? Whoa, 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 whoa. You have three things multiplied together. Does it matter the order in which you multiply them? No, it doesn't. So the negative, whatever, it's the same thing, right? Write it whatever order you want it to. It's the same thing. Are you okay with that? Yes? Okay. Wasn't so bad, right? Probably the trickiest piece was taking the negative 1 out to start. If you manage to do that, everything usually works out pretty well from there. Isabel. Yes. Olivia, are you happy here, though?
I'm very happy.
Okay. You said 2A? Okay. All right. Isabel, you asked about this one. Which side did you want to work on?
The left side.
Okay. What did you do first?
I foiled. Oh wait, yeah, I foiled.
Good. So what Isabel said is that she thought about cosine x minus sine quantity squared as cosine x minus sine times cosine x minus sine, and she foiled this out. I'm going to skip like a little bit of the foiling step and just write the final answer after we foiled it out. Is that okay with everybody? So if you don't trust me that that's what you get when you foiled it out, you could do your first outer inner last, multiply it out, but I promise you this is what you get. Isabel, you happy with that?
Yeah.
Okay. Well, I see something right away that sticks out at me. Yeah, Anna's got it. Anna says I have a sine squared plus a cosine squared, which is 1. And then I'm done. Wasn't so bad. You want to do 2b? Or not 2b? Yeah. So it matches the identity sheet. Again, no. So I tried to be, like, I over-explain things often on the answers because I want it to be clear. So try not to get confused by extra work, sort of thing. So that's what I would say there. All right. Olivia, you said you want to do 2b. Okay. Here, do you think it matters which side you start on? Well, it's two things being combined either side, right? Left or right. So to me, it doesn't seem like it would really matter. That's my thoughts. Let's start. So you want to start on the left-hand side? Let's do it then. All right. So what would you suggest doing first? So Sam says, let's factor out a tangent squared. Sure. Oops, thank you. Everybody okay with what we did there as the first step? There's just the greatest common factor of tan squared. Good. So Olivia says that the inside part is secant squared. Good, I agree. And Sam says he can turn tan squared into secant squared minus 1 using the same identity. And then you distribute them out. Exactly right, Bella. And we get exactly what you're supposed to.
Here we go.
I'm pretty pleased with how quickly that came together. You guys, Isabel?
We do a collaborative test.
3C.
What for like teams?
3C.
We should do partner time.
Not this time.
Alright, so we can start on the get a common denominator.
Okay. So, you guys, which side did you say you want to work on?
Right side.
Left.
Right side.
Left.
Right side.
Left.
No, right side. Me and Isabel say left. Right, because then you just multiply one time. Right side. David, have trust.
It looks worse.
Have trust.
I mean, Sam's kind of right, but if you want to work on the left-hand side, that's fine. So the only issue is it gets a little bit messier there, but it's not terrible. So what makes me think to work on the right-hand side is these 2's. Because really the only way those 2's are going to get there is from like foiling something out. But we can certainly do this from the left-hand side. Now, it's a little bit trickier on the left-hand side. If we were to work on the left-hand side, what would be the first thing to do? I'm going to turn 1s into sine squared plus cosine squared. You know what? We'll do them concurrent. We'll do it concurrently. How's that sound?
Like at the same time?
Yep. It is one step, I know. Okay. I rewrote the 1s as sine squared plus cosine squared. Okay. On the top, that factors into sine x plus cosine x quantity squared. Because if I look at this, this is really like x squared plus 2xy plus y squared is what I see up there. Where sine squared x is like x and cosine squared x is like y. That's why I told you the right-hand side is going to be easier. Why I said Sam was right. And if I combine like terms in the denominator, I get cosine squared minus sine squared. Now, if I FOIL things out in the numerator here, going from the other approach, and FOIL things out in the denominator, get that. So back to doing the left-hand side. The denominator on the left-hand side, I notice is a difference of 2 squares. So I can factor that. Where I notice that those guys cancel, and I'm done. If I go to the working from the right-hand side, in the numerator I see sine squared plus cosine squared, so that's a 1. And in the denominator, what am I supposed to get to? Okay. I know I can turn sine squared into 1 minus cosine squared. And when I distribute that negative and combine like terms, I get 2 cosine squared minus 1. So you could work from either way. It took me the same number of steps either direction, right? I find that it's typically easier for students multiplying things out than it is to like factor things down and cancel. but you notice that the two directions were remarkably similar. At one point, like, we had the same things in the numerator. One, we factored it away to make it what the other thing started with, and the other, we multiplied it out to get to that factored, But does that satiate everybody's needs here for 3C? I did it both ways for everybody. Are we happy with that one? Isabel? Yep. Can I move on past this one, or is people still writing here? Okay. There is no D for number 4? Oh, B is in boy. Okay. Great. So, which side did you want to work on?
I think we should start with the left.
Okie dokie.
Maybe I'm wrong. I don't know how to really.
So, the left is fine.
But the right is better.
Nope, I don't know that it is. The right is fine. So, what I see when I look at this right away is that I have cosine times something, right, on each of these. So, that's what I would start by doing, is just pulling off a cosine, because I'm not touching that guy again, right? So I got that part of it. Now somehow sine cubed times cosine squared has to turn into sine cubed minus sine to the 5th. Since that piece is all in terms of sines, I'm going to rewrite cosine squared as 1 minus sine squared. Because I know I don't have any more cosines in my answer. All I have is sines in that part, so I'm going to just turn that cosine into a sine the only way I know how. And what happens now? Yeah, I just distribute. And I have exactly what I need. Whoa! Not too bad.
Not too bad at all.
Not too bad at all.
I don't mind that one.
What would I have done had I worked on the right-hand side? I would have started by factoring out the sine cubed. And then what I would have been left with is the 1 minus sine squared, which I turn into cosine squared. And then that times cosine is cosine to the 3rd, and I'm done. So, it's about the same way, about the same thing doing it on the other side. Which is what I'd expect, because if I look, I have one thing on the left-hand side and one thing on the right-hand side. Shouldn't really make any difference which side you work on. Be the same number of steps. What do you guys think? Joanna? This one here? Okay. So Joanna, which side did you want to work on first? I agree. I'd work on the left-hand side because it's a difference rather than a product. Okay, what did you want to do first? Great, I would do that. And if I'm going to do that, I should make a common denominator with the other one, right? So I'll multiply that by sine squared over sine squared. Everybody so far so good? So if I write this as a single fraction, have this. Now look in the numerator. I see a greatest common factor. Right? That greatest common factor is cosine squared. So let me take that out. And I'm going to put it all the way out front because that cosine squared is going to be that cosine squared. So I know I'm not going to monkey with that anymore after I got it out of there. Happy with that? When I look in the numerator now, what do I see? I see 1 minus sine squared is the same as cosine squared. And then cosine squared over sine squared is cotangent, and I am done. To do it the other way, I would have turned the, if I worked on the other side, I would have turned the cosine squared into 1 minus sine squared, and then distributed. And then if you have the sine squared times cotangent squared, the sines can't, when you turn then the cosine squared over sine, that's where the cosine comes from. So you can do it from that side also. Really no different. Or no more work anyways. Isabel. This one? Okay. Which side did you want to work on? Yeah, this one's a no-brainer, right? I don't know. If I looked at this, I'd have no idea how to get that. Well,
I don't even know what that is.
yeah, it would take a lot of work to get that to the right-hand side. So, definitely working from the left. Okay. What did you want to do first?
Get common denominator.
Okay. What would that common denominator be that you're looking to get? Okay. So that's going to give us sine squared over sine x times 1 plus cosine. Oops. I'm going to turn these all into x's apparently, so you just got to roll that with me there. So far, so good. Okay. All right. Let's FOIL out the 1 plus cosine squared, probably. You good so far? I see the end now. So in the numerator, what do we notice? Sine squared plus cosine squared is 1. So 1 plus 1 is 2. So I'll write it that way. Everybody okay with what I just did there? Okay. Look in the numerator. What do you see? Greatest common factor of 2. And now it's obvious, right? The 1 plus cosines cancel. And 2 over sine just turns into 2 cosecant. And we're done. Would have been rough starting on the right-hand side, having to rebuild all that out of 2 cosecants. Probably would have just worked the same steps in reverse. Raul. Of course. David. You can go too if you need to. I had a feeling when you said never mind, that must be what you're after. Alright. Shall we move on to the other things here?
Yeah.
What? You should be able to add and subtract and simplify fractions appropriately. Yeah, you should be able to deal with fractions and be able to go, okay, is 11 pi over 3 inside of 0 to 4 pi? Yes, I'd expect that you're able to do that without a calculator. Wasn't that on the last test? Probably, to some extent, yes. Okay, so this was the section 1 homework. Which problem did you say you wanted to look at? Well, I can't probably do all of them. 1 and 2. Okay. All right. So, for 1, we know cosine is that. That's 1 down, 5 to go. What other one can we get immediately from this? Secant. What's secant theta got to be? The reciprocal. 2 down, 4 to go. Everybody so far so good? All right. Now comes the tricky part, is we have to find the other 4. So the first 2 are easy. Whatever you're given and then its reciprocal are easy to get. Well, we're going to find all 6 here because I think that's what I asked you to do on the test. So, if you can find 1, you can find 6. All right. So, what I'm going to do now is, I want to figure out what the value for tangent is, since I know what the sine of tangent is. Sound good? Which identity relates secant and tangent together? Or cosine and tangent together. You could do that too, but secant and tangent is the one I want. It's P3. So, that says that tan squared plus 1 is equal to 4 squared. Because secant squared, or secant is 4. So that tells me that tan squared is 15. Or tangent theta is plus or minus the square root of 15. And since tangent theta is negative, I know that it's just negative square root 15. 3 down, 3 to go. What do I get immediately from this? Cotangent. What's cotangent have to be? Negative 1 over the square root of 15. Should we leave our answer like this, though? No. What should we rationalize? We should rationalize this denominator to make it negative square root 15 over 15, right? Four down, 2 to go. Everybody okay there? Okay. So now we just need something that it relates sine to either, well, probably really we need to relate it to tangent because we need to know this. We can't use a sine squared because we have to figure out the sine. We just need regular sine. So I'm going to relate sine to either tangent or cotangent. It doesn't really matter. So I know tangent is equal to sine over cosine how about 4 times, or yeah, negative square root 15 over 4. 5 down, 1 to go, but that next one is really easy, right? It's the reciprocal. Multiply both sides by 1/4. Yeah. But we wouldn't write it like that. We'd rationalize the denominator. So there's my 6th one.
So you're going to ask us to do business problem with both reference triangles and...
You should be able to do it either using a reference triangle or using identities. I'll tell you which one to use, or if I don't, you don't have. You can use whichever one you feel like. But you should be able to do it both ways. Yep. Sure. One down, 5 to go. What do I get immediately for free here? Yeah? Okay. It doesn't matter where the negative goes. Right? Standard to put it on the numerator. Or out front of the fraction. Okay, 2 down, 4 to go, right? Now I want to find a way to relate cotangent to either sine or cosine. So that's going to be using P2. And since it's plus or minus, but I know cotangent is positive, I get rid of the plus or minus and just take the plus. And let's simplify that. So I have cotangent is 2 root 2. What do I get for free now? Tangent. But we don't want the root in there, so let's rationalize the denominator. So I have 2 root 2 over 4. I'm sorry, root 2 over 4. My apologies. I wrote the right thing, I said the wrong thing. We still need cosine and secant, so I will use either cotangent or tangent to get those. Doesn't matter which one. So let's just say we'll use cotangent. So I know cotangent is equal to sine over cosine if I multiply both sides by cosine and then divide by 2 root 2, and then we rationalize the denominator, get that. And what do I get for free? Secant, which is just going to be negative 6 root 2. Notice I got that quickly by just taking the non-rationalized answer for cosine and flipping that. Which makes life just a little bit quicker. A little bit. I think I did that all right, didn't I? I think so.
So what would happen if you didn't take the rationalize? You just have to do more work, or?
Well, if you flipped 12 over root 2, then you have to rationalize. Yeah, and then you have to reduce, because you'll have 12 root 2 over 2. Which turns into 6 root 2. I mean, it's not much more work, but like, yeah, there's like one less place to make a mistake and all that kind of stuff. Okay with those? You guys remember doing that? Yeah. And we overkilled 1 and 2. Obviously, I ignored the directions and did way more than I needed to. But they're not bad, right? Yo. Which one do you want to do? So we're going from the problems. This is what you're talking about, right, Isabel? Yeah. Okay. Yep. Just a minute for it to paste. It's a big. Yep. It's a big copy. I can, yes. But I'm waiting for it to paste right now, so I can't do anything. Because there's a big paste that I just did. But yes, I will be zooming in shortly. Isabel, I think I just give you one interval to solve over. I don't remember specifically, but okay. And you were interested in 25, you said, right? So, first thing you should do is Divide by 2. Then what? Yup. When you take the square root of both sides, what do you have to remember? Plus or minus is. So we're going to break that up into 2 separate. Good with that? And so what I'm looking for then is on my unit circle, where tangent gives me negative square root 3, and where tangent gives me positive square root 3. If I go there, I remember that tangent is sine over cosine. So this happens at pi over 3. And then this one happens at 2 pi over 3. And then this one happens at 4 pi over 3. Oops. 4 pi over 3. And then the last one happens at 5 pi over 3. Okay with that, Isabel?
Yeah, you're just like doing it in there.
Yep.
Just to be clear, when you're looking at a unit circle, it's always like the inverse, so it's like tan inverse, sine inverse, cosine inverse, like that's always the resolution. Nothing else.
Yeah, the way that I go from here to find the values of x's, so the inverse function gives you an angle back.
Oh, yeah.
So that's why I wrote the inverse tangent of square root 3.
Okay.
So you have to find it in the range, the natural.
So depending on now what we're asked for, we should be able to find answers inside of whatever range of values that we're asked for. So we could use the values on the sheet, or if you guys want to make up your own values, we can find the answers in some other range. Doesn't matter.
You didn't give us like the intervals that were assigned in the homework, or you didn't make up.
Not necessarily. I should be able to give you any interval, and it should be fine.
What? Actually, can you make up your own interval?
Give me something. So let's say we want the x's on 2 pi and 6 pi. Okay, that's fine, Bella. Do we have parenthesis at 2 pi or a bracket at 2 pi? Bracket, okay, at 6 pi. Parenthesis, okay? Everybody okay here? So when I see this, what I see is I'm going to find something from 2 pi to 4 pi, and then also something from 4 pi to 6 pi. So all I'm going to do is I'm going to find the things in between 2 pi and 4 pi, I'm just going to take my unit circle answers and add 2 pi to those. And to get the things between 4 pi and 6 pi, I'm going to take my unit circle answers and add 4 pi to those. That's it. Everybody okay with the reasoning why? So let's say there's a value of my unit circle, right? That answers between 0 and 2 pi. Everybody agree with this? Okay, so you guys that just asked for y, and now we're talking to Jackie instead of watching my explanation, is a little bit frustrating for me. So this answer is an answer between 0 and 2 pi, right? If I add 2 pi to that, I'm at the same spot, but now my answer is between 4 pi and 6 pi, right? And if I add 4 pi, I'd be here, and I'd have an answer between 4 pi and 6 pi, right?
So like, to start your range, just add whatever that is.
No, No. No. Not necessarily. For these, yes. If those were odd values of pi, you definitely can't do that. Let's finish. Okay, so you're happy with this. So let's do another one then. We didn't know, but I told you what all you had to do was add 2 pi to your answers and 4 pi to your answers. Okay? And that'll give you all your answers that you need. So what answers are you, what ranges do you want to do then? That's fine. Everybody okay here? All right. So when I see this, the way I'm going to think about this is I'm going to think about negative 4 pi to negative 2 pi, and then negative 2 pi to 0. Okay? So to get the answers here, I'm going to be subtracting 2 pi. To get the answer there, I'm going to be subtracting 4 pi. Right? So if I do that, if I subtract 2 pi, when I subtract 2 pi from pi over 3, I get negative 5 pi over 3. When I subtract 2 pi from 2 pi over 3, I get negative 4 pi over 3. When I subtract 2 pi from 4 pi over 3, I get negative 2 pi over 3. And when I subtract 2 pi over 3, when I subtract 2 pi from pi over 3, I get negative 5 pi over 3. Hold on a second. Sorry. Sure. Whatever. For this problem, it's irrelevant. Sorry. Well, because are any of these values multiples of pi in my answers? No. So can I ever have a value that's at the endpoint to where it matters? No. Sorry. Okay. All right. So I subtracted 2 pi from each of my 4 answers, giving me these 4. Now, I need to check which one of these answers are between negative 3 pi and negative pi. Those 2. The other 2 are too big, right? Okay? Now if I subtract 4 pi from each of these, I would be negative 11 pi over 3, negative 10 pi over 3, negative 8 pi over 3, and negative 7 pi over 3. Which one of those answers are in the range between negative 4 pi or negative 3 pi and negative pi? Just those 2. The other ones are too small. Right? Negative 10 thirds is less than negative 3. Negative 11 thirds is less than negative 3. Yes. Turn off the lights if you guys can't see. Because you don't need it. Why? Because you can't add fractions? Raul. Bracket means the value is included in the set. Parentheses means that value is not included in the set.
I just feel like we're going to be wasting our time subtracting fractions, and that's not part of the set.
I don't know that it's how much time you're really going to be wasting. So 2 pi, all the denominators are 3, I'm just subtracting 6 pi over 3. So I'm just subtracting 6 from the numerators. Like, you can do that in your head without having to write anything down. Like, as a junior in an honors class in mathematics, fractions should not be like the thing that's scaring you the most about the test. Like, with all due respect. And again, how much of a penalty do I give you if you have, like, you goof up a little thing versus you have all the right work? Yeah, I am very lenient about little mistakes when you have the correct idea and you goof something else up. You're right, but there's one problem where you have to deal with the fractions. Just one. Right? It's not like I'm asking you. That's if that's 1 point per problem in all or nothing. Since when have I ever given like all or nothing 1 point problems on a test? The homework quizzes are never all or nothing. You cannot argue with me about how I've been grading the homework quizzes. Okay, do better then. I haven't made any decisions yet. Sam. Okay, so Sam says, how do I know when to worry about using the natural range? And the answer to you, Sam, is if you're solving, never. He asked, when do I have to worry about using the natural range? Like that the answers from my calculator only come between, negative pi and pi. Or whatever. So, in a problem like this, where we're solving for x, or you're given an equation and asking for the values of x in this interval that satisfy this equation, you do not care about the natural range at all. Other than, like, if you had to use your calculator to do this, knowing that you're going to have to convert your calculator answer into a value inside of the range that you're looking for. Or find the other answer that the calculator wouldn't give you that's also inside the range that you're looking for. But if you're using the unit circle to do this, like we've done for all of these problems, it does not matter. Is that as clear as I can make it for this test? Okay. Yes, Olivia. Well, again, let's get through this test, and then we can start thinking about what the end of the semester looks like, okay? You just kind of getting the cart before the horse a little bit here. Okay. Do you have some more that you want to ask about? Is there more things? I tried to answer these questions, like particularly this solving question with the intervals at the end, like as generally as I could, so it wasn't like hyper specific to this one problem. So it's the same idea, it's the same thing as like one of these kind of problems. So the idea here would be, if I know cosine is positive, I know I'm looking in these two quadrants. And if I know tan is negative, I'm looking at one of these two quadrants. So my triangle that I'd be drawing is here in this quadrant. The hypotenuse for this triangle would be 4, and the adjacent side would be 1. I can then use the Pythagorean theorem to find this third side. And because it's pointing down, I know that has to be a negative because it's in the fourth quadrant. And then I just evaluate using my right triangle definitions of sine, cosine, tangent, cotangent, secant, whatever. That's finding the exact value of the trig functions from given information. So, again, if I don't tell you how I want you to do that, Andrew, you're welcome to do that. If I tell you to use identities, you can't do that. I mean, you can do it to check, but, like, it's not going to get you full credit. Correct. I could do either. I could be specific. You should be able to. You should be able to do it both ways.
Okay. So how would you describe this test? How do you project it?
I think if you usually do good, you should do good. If you usually do bad, you'll probably do bad.
That's hilarious.